Morning, welcome back. It's day 14. Regolith Reservoir. Well, let's get... So that's showing the coordinates that something moves through. They're not all steps of just one. In fact, most of the ones I've been able to catch seem to be steps of 4. Not all of them. 25,000 characters. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Correction, the distress signal leads you behind a giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave, okay? If you don't quickly figure out where the sand is going, you could quickly become trapped. Fortunately, your familiarity with analysing the path of falling material will come in handy here. You scan a two-dimensional vertical slice of the cave above you, your puzzle input, and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path, where X represents distance to the right and Y represents distance down. Each path appears as a single line of text. Okay, so are these coordinates of vertices? This scan means there are 2 paths of rock. The first path consists of 2 straight lines, the second path consists of 3 straight lines. Are all the lines orthogonal? I think they might be. The first path consists of a line of rock. Sand is pouring into the cave from point 500, 0. Okay. When rock is hash, air is dot, and the source of sand is plus, this becomes this. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill 1 tile of air. A unit of sand always falls down 1 step if possible. If the tile immediately below is blocked, it attempts to move diagonally, down left. So we want to go down, down left, down right, and then stops. All further sand flows out the bottom. Okay, so the sample input is 24. How many units of sand come to rest before sand starts flowing out the bottom? Okay, that seems relatively straightforward. It just depends on the size of the grid. So it might be another one where we first get the bounds and then solve the problem. I'm thinking we use the input data to plot the hashes in a... we can have 2 bitmaps. Would work quite well. Anyway, silent contemplation. Well, first let's get the bounds. maybe that'll work. Incorrect. So I guess the first one it's very annoying to pass, isn't it? Okay, that works. So now we want to know the bounds. Three, four's not right, is it? Why are we consuming the 5 and the 0? I know what to do. This is so annoying. Maybe I can't do it with scanf. Because of the thing where scanf reads an extra character without telling you what it is. Okay, fine. I can't remember how long the longest line is. Oh, this is awful. Okay, here's what we're going to do. Okay, that hasn't worked. Maybe we can do. Good. I think. Is it 2 and then 3? No, we've missed the final one. I think it's passed it wrong. Because there's no zeros in here, are there? Oh, I don't think that's how you use head. But I remember that. Well, that works. But that doesn't work. Oh. Well, the line's longer than 256, is that the problem? No. So after 503.147, it thinks it's reached the end of the line. But now it works. Maybe. Oh, it's 1 to 8. Okay. So it's that. In fact, just to be on the safe side, I'm pretty confident it's that. Fine. I don't think that should present a problem. 71 by 165. We don't even need to use the bitmap. In fact, I think we might not use the bitmap. Well, we're 27 minutes in and we're correctly reading the input. Let's widen this a little bit. Y range. In fact, do we even need the sand to be stored separately, or do we just plot sand in the walls? Okay. Putting these in a gra is kind of pointless. Could just do it as we go. Okay, so that's our walls. Now, finally, simulate sand. So we attempt to go straight down. I made an infinite loop. Oh, min y is 0. because we need to be able to plot things above. Like widen these just slightly more. So the first piece of sand never comes to rest. Oh, why should be increasing, not decreasing? Down is positive. Okay. Close. It gives us 23. Only 2 more units of sand. It'd be interesting to be able to plot the grid, wouldn't it? Well, let's just do what will fit on the screen. Return needs expression. I didn't write return, did I? Okay, I did. Okay, so I can see the tile that we're not putting sand in. It's the one in the backwards L. Why would we not put sand in it? Oh, hang on. Always falls down if possible. Oh, I know what the problem is. My add wall should be that. has that not worked? I did notice that I'm still updating min-x and max-x in the input reading thing, which I don't want to do. Oh. Okay, what we'll do is oh, so annoying. Since it was relatively slow even on the sample, I think it's worth compiling to run on the real one. Slightly confused about that one dot of sand that has a gap next to it. I will just check that on the problem statement, because if I'm not putting the sand in the right place, then it's not going to work properly. Okay, fine. Oh, because it slides off and then goes straight down. No, I've got no idea how large we expect the answer to be. The bounds of the grid was about 11,000. Which would be 130, 140 lines of output. But it could probably be only half that much because it's triangular. So maybe 80 lines of output. And probably it's not going to fill the whole thing up because it'll have, well, at least it's got walls in it. And it'll have voids as well, I expect. So maybe we're expecting an output about 50 times 80, about 4,000, which would be 2 screenfuls of dots. Maybe a bit less, maybe about 1 screenful of dots, maybe about 2,000. You realise you misread the scan. There isn't an endless void at the bottom of the scan. There's floor and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y coordinate equal to 2 plus the highest y coordinate of any point in your scan. So the floor is at 180. In the example above, the highest y coordinate is 9, so the floor is at y equals 11. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at 500 0, blocking the source entirely and stopping the flow of sand into the cave. So I'm wondering, do we actually simulate all those pieces of sand Or do we simply say, once the sand has blocked off all of the walls, we know it's just going to fill up in a triangle? Well, my thing is 180 tall. So that's going to be 16,000 pieces of sand on each side. So 30,000 pieces of sand in the triangles, potentially. Oh no, it's only 16,000 pieces in total. Okay, so we've got a 180 by 180 square region with some walls within it, and we want to know how many points within that region will sand settle at. Now, sand will settle at a point if there's a route from that point to the origin that only takes moves that go vertically up left or up right. So instead of simulating each piece of sand, what we could do is well, we could start at the top and do like a depth first search where we go down and we just add 1 for every point we visit, and we don't visit any points more than once. So all the sand needs to be less than floor Y. So drop. We'll have drop return how many pieces of sand there are in total. And the way this is going to work is not a while loop anymore. Since we're going to be calling that a lot of times. Okay. So we'll simply return drop x y plus 1, drop x minus 1 y plus 1 plus drop x plus 1 y plus 1. Oops. Oh, but the floor in the sample is 11. Must remember to change that back. is that 0? Oh. '93, great success. It's actually faster than part 1. Oh, must change the floor Y. So this is going to have 180 levels of recursion. Do we think that's going to overflow the stack? Well, are there more than about 10 words of stack space required? No, because there's no globals. There's no locals, there's parameters. So we've got 1, 2, 3. Oh, it'll be tight, but I think it'll be fine. I wonder if it will still be faster than part 1 on my real input. Oh, it is. Too low. Why would that be too low? I don't think that's the problem though. I think that's all still within the bounds. Oh, it needs to be 180 wide, doesn't it? By 180. It's not going to fit in memory. I'm pretty confident. In which case, we need to make it a bitmap. Must remember to change the floor. So, anything that operates on grid. And we do not distinguish between walls and sand anymore. We're not using the map function or the plot function. Draw grid's not going to work. Did I delete the map and plot functions? Because draw grid still calls map. Annoying. Okay, good. Oh, hang on a minute. If we go down 180, we can go across 180 as well. So that's going to be 360 by 180. It's 65,000. Yeah, there's a bitmap, but that's fine. Not sure how long we'd really expect this to take. Might be interesting if I knew how much slower a bitmap was than a direct array access. Okay. Excellent. Oh, Harry Freeber beat me again. As did quite a few others. Yeah, well, it did take me almost half an hour to pass the input. Anyway, thanks for watching. Goodbye.